we introduced Menge, a modular framework for simulating crowd movement. There is a common paradigm in crowd simulation, which decomposes the problem into a set of related subproblems. They are goal selection, path computation, path adaptation, and spatial queries. This paradigm appears frequently in the literature. Unlike a tightly coupled, monolithic simulator, Menge is a cross-platform, modular framework. It exposes each of the subproblems in an extensible interface, allowing the user to mix and match implementations to create a novel crowd simulator. Out of the box, Menge is a complete simulator. It includes basic implementations of solutions for each subproblem. With these built-in tools, many interesting scenarios can be simulated. However, Menge's greatest strength lies in its extensibility. Novel solutions to subproblems are easily integrated with Menge by implementing a simple interface. This modular framework provides several benefits. Focused development. Users can focus on a single subproblem, relying on pre-existing implementations for the other subproblems. Efficient dissemination. Novel models can be released into the framework as code or as binaries, allowing other users to benefit. Meaningful evaluation. Novel models can easily be compared against other implementations in the framework, making algorithm comparisons meaningful. Bespoke functionality. Special functionality can be introduced as dictated by simulation needs. In this video, we will give a brief overview of the architectural details and then illustrate Menge's benefits with a series of representative simulation scenarios. Depending on the scenario, an agent's goal can change from moment to moment. Menge uses a behavioral finite state machine to model this. The specification of the BFSM ultimately defines how an agent interacts with other agents and its environment, and how those relationships change with time. The mechanism in Menge responsible for path computation is the velocity component. At every time step, the velocity component reports a velocity for the agent to travel to optimally progress towards its goal. Typically, the velocity component only considers static scene elements in devising its plan. The velocity component's simple plan may prove to be infeasible in the face of dynamic constraints. Menge uses a pedestrian model to map the recommended velocity to a feasible velocity. In the literature, this is also referred to as a steering or local navigation algorithm. Finally, Menge provides the spatial query object to perform visibility and proximity queries.